my name is Chantel, and for this video, I'll be showing how to get started with VUnit and using Riviera-PRO as VUnit's simulator. VUnit is an open source framework designed to automate unit testing and verification in FPGA development. Through automation, it complements the existing testing methodologies using a test early and often approach. VUnit brings in many benefits when integrating with Riviera-PRO. Not only is its integration seamless with Riviera-PRO's simulator, but it also reduces testing overhead by supporting automatic discovery of test benches and compilation order, as well as including libraries for common verification tasks. One of the engineers here at Aldec has recently published a series of blogs on our website introducing VUnit and exploring a practical example that demonstrates VUnit's integration with Riviera-PRO. I highly recommend giving them a read. So I've linked the blogs in the description below, as well as Aldec's GitHub that contains the example design used in the blogs. So without further ado, let's get started with VUnit. There are a few things to install and set up before we can get to using VUnit with Riviera-PRO. The first thing to do is to make sure that you have Python 3.7 or greater installed, since the entry point for executing VUnit is a Python script. For me, I already have a Python version greater than 3.7, so I'm good to go. Next, you'll need to install VUnit itself. To do this, use the command pip install VUnit_HDL. If there are times where you need to install multiple Python packages, including VUnit, use the command pip install-r.txt file name, where the text file contains all the required Python packages and their versions you'd like to install. I'll now run the pip install VUnit_HDL command and show that it's already been installed. Now that we've confirmed those two, we now have to set the path variable to Riviera-PRO by adding the bin directory to the path environment variable. Once that's done, we have to set Riviera-PRO as the default VUnit simulator with the command set VUnit_simulator equals Riviera-PRO. Later in this video, I will also show how to set these two things in the run.py script that will be used to execute VUnit. This will add robustness to the script, which can be helpful if there are different operating systems using the same script. With the prerequisites out of the way, let me show you the example design I'll be using for demonstration. The example is called Test Plan Rank, and to find it, go to Riviera-PRO's Examples folder, go into Coverage, then into Coverage Database, and then you'll see Test Plan Rank. The main function is a base 64 encoder, and the main purpose of this example is to demonstrate a verification methodology where it will run through all the prepared test cases to obtain coverage results. And these results will be used then to see if it fully meets all verification requirements in the given test plan. Each test uses one of the messages located in the input file, and there are 6 of these. Some of the tests will end up redundant, so this design will also be using the acdb rank command to find each test case's contribution results, rank the contributing tests based on their results, and identify the redundant tests. So now that we know what this example does, let's get it to work with VUnit. I already have an edited version of this example. If you'd like to follow along, this edited version is available to download, and you can find the link to that download in the video's description. The main file that's needed to run VUnit is the run.py Python script. This should just be located in the main working directory, as you can see here. In this example, the OS and path are also imported so that the code can be used across different operating systems. And just a few lines down, going back to what I mentioned earlier about adding robustness to the script, I've added these 2 lines of OS functions to set the VUnit simulator and path to Riviera-PRO, so that you don't have to always use command lines, or go to your operating system's settings to set the path. This script also contains the fundamental components of a VUnit run.py file. This includes creating a VUnit instance from the command line, adding VUnit's built-in HDL utilities for either VHDL or Verilog, or in this case the design uses Verilog, creating the library, adding sources to the library, and lastly, running the VUnit function. For this particular example, there are other commands added to this file for compilation and simulation options. In order to get ACDB coverage for ranking from VUnit, the command setCompile option is used, where the parameter to set Verilog compilation options is called Riviera-PRO.vlog_flags, followed by all the arguments needed for ACDB coverage, which are contained in these brackets. The other command needed is the setSim option, which configures the simulation settings. The first use of this command enables coverage. The second instance sets the Verilog simulation options using the parameter called Riviera-PRO.vsim_flags, followed by arguments needed for ACDB coverage. The last instance uses Riviera-PRO.init_files.before_run, which runs a file before the simulation runs. In this case, the toggle.do macro is used so we can get toggle coverage. Lastly, this example design does output its encoded results to an output folder, so there's also a command that creates the needed output directory. And that sums up the run.py script for test plan rank. Now let's move on to the test bench. The test bench in the original example is not VUnit compatible, so to make it compatible, some changes were made. One key line to add to the test bench is to include VUnit_defines.svh, so that it can use VUnit functions and constructs. In the original test bench, the tests were done using a case statement inside of a generate construct. In the edited test bench, this is replaced with test suite begin, where inside of this test suite, you start with test suite setup, and then follow it with test case. Inside each test case is where you want to use the necessary functions to perform the test. For each test, the respective input and output files are opened, and the function called test is used. Going down towards the end of the code, test is an automatic task where it performs the encryption. If the encryption finishes successfully, the test passes, and if the encryption fails, the test fails. In the original test bench, this test task is just the main initial begin block. Going back into the body of the test suite after the last test case is test case cleanup. This occurs after the end of every test case to ensure that the next case will run without conflict from the previous test case. And lastly, this test suite cleanup will run last before the test suite block exits to ensure a clean finish. The rest of the test bench remains unchanged from the original one. And one last thing to note is that this is how to make a Verilog test bench compatible with VUnit. Making a VHDL test bench compatible is different. You can see how on the VUnit website user guide section, which is linked below in the description. And the aldec blogs I mentioned earlier also use a VHDL example, so please look at those sources. Now you know how to set up a VUnit run.py script and make a VUnit compatible test bench. So let's go ahead and finally run the run.py script. Open up your terminal or command prompt and move into the working directory. So for me, it will be my designs, and then test plan rank VUnit-main. From here, just type out Python run.py. And VUnit will begin to run. It will first compile all the necessary libraries and files to run the simulation with VUnit. And then you could see that there will be an output message for each test showing that it has started, followed by where the output file is, and then shows whether or not the test passed or failed. At the end, there's a summary showing the status of each test along with how long it took to run each test. You can see that all the tests have passed. When VUnit finishes running, there are some new files added to the working directory of the design. VUnit produces a new folder called VUnit_out. In here are folders for the project database, files for Riviera-PRO since we used Riviera-PRO as our simulator for VUnit, and test output. Inside test output are folders for each test conducted, producing files for Riviera-PRO like ASDB and ACDB results, and the simulation output if you wanted to see the verbose details of each test case's simulation run. With all the tests passing, I'm going to run the example's runme.do macro, using the coverage results that were generated from running VUnit. In this runme.do macro, each test output gets prepared for merging, and then afterwards, the testplan.xml file gets converted into ACDB. Each test output then gets merged, and then both the ACDB coverage and ACDB rank reports are generated. From there, it will finally open the results of each report within the Riviera-PRO GUI. So in the command prompt, I'm going to type riviera-do source/runme.do and press enter. A new instance of Riviera-PRO opens up, and you can see the console running the commands of the macro. And finally, we have our two reports. In the ranking result page, if I expand contribution tests, I can see that test 5 contributed the most to the test coverage, followed by tests 3 and 1. Expanding the redundant tests, I can see that tests 2, 4, and 6 did not contribute anything unique to the coverage. In the coverage report page, we can see that all forms of ACDB coverage were 100% covered. In going into the verification plan and expanding each type of coverage within the test plan, it shows that all parts of the verification plan's requirements were met. Now I'm going to go to the original example's designs macro and run that. Looking at the ranking report, the VUnit results are identical to the report of the original example. And in the coverage report, the VUnit report also matches the original example's report. And that's about it for this demonstration of VUnit with Riviera-PRO. This all shows how robust VUnit is as an open-source unit testing framework, and when combined with Riviera-PRO's simulator, there's so much more you can accomplish with testing over a shorter period of time. Again, if you are interested in reading more about VUnit with Riviera-PRO, or even with ActiveHDL, please check out the blogs linked in the description below. Don't forget, I've also linked the main VUnit website, as well as the Git link to the VUnit compatible version of the example design I used in this video. Thank you for watching this video, and happy testing!